Hi, everyone. My name is Jeremy Ames, and I'm in a group with Rabbi Radman and Mustafa Faran. And we're going to be talking about some models for forecasting for investments. This is to help amateur investors complete their due diligence when investing in stocks. I'm going to take a little time to talk about the introduction, to set the context and discuss the problem statement. And then I'll talk a little bit about one of the models, while Rabbi and Mustafa will talk about some of the other models. I'm going to move relatively quickly through this, just to make sure we have time to talk about these models, because they are interesting. We do have our references at the end so that you can go through and check those out. Now, we arrived at this idea for investments and helping with that with the realization that consumer debt is quite high. And it's been increasing, it's been trending upward for about 50 years. And we don't see that changing anytime soon. In addition to that, there's a lot of uncertainty now around pensions, and also with the rise of the gig economy, more and more people will be arriving at that retirement age without the funds to do so. And we see investments as a way of solving that problem. Now, investments has its own issue, though, that when investing, there's so much information, there's so many gurus, and often that can be conflicting. And what that means is that amateur investors, for example, who have gut feelings about stocks, can find information that will validate those decisions no matter what those decisions are. So we're trying to root that in something, in forecasting models that can help them. Because we see gut feelings as being very risky. Not that different than going to a casino and betting money in that and hoping for the best. Now that leads us to our problem statement, which is to help amateur investors to test some models that can help ground them and can tweak their investment performance. Now, the four models that we'll be looking at is Power BI forecasting, ARIMA, Tableau forecasting, and portfolio optimization. I'll start with Power BI, and then I'll be passing it over to Rabbi, and then over to Mustafa. Now for Power BI, I'm going to switch over to the program from the PowerPoints, just so you'll actually get to see the program and the demo we put together. The PowerPoint's still a useful reference information in case you want to recreate yourself. Now you'll notice I've done a couple things already. I've uploaded the information or uploaded the data. I've chosen Apple for this demo, and then I've also chosen the line chart. The line chart is because by doing that, we can also get our data analytics on this by choosing this icon, and then we can scroll through all these different options down to our forecasting. Now with forecasting, I've chosen the auto seasonality and gone with an interval, confidence interval of 90%, and then over 2 years. So using our data to abstract to the next 2 years. You'll notice it's pretty wide, but also pretty positive. Now the way that I can test that out is I can actually ignore the last 2 years, and you can see here that it actually outperformed my forecast. Apple did that, and that was a trend that we saw based on our data sets, was that the Power BI forecasts were a little bit conservative compared to the actual results that we received when we ran all the different data, like including Microsoft, for example. Now I'll pass it over to Rabbi, though, for his model discussion.
Thank you so much, Jeremy, for the introduction. Good evening, everyone. My name is Rabbi Radman, and I am a data scientist. Today, I'll be talking about predicting using ARIMA model together with forecasting in Tableau. So ARIMA stands for Autoregressive Integrated Moving Average, and as you can see, the first two letters AR are referring to the p-value, which is the autoregressive lags, and the I letter refers to the D, which is the differentiation, and the last two letters, moving average, are referring to the Q, and these are the major components of ARIMA model known as PDQ. So ARIMA general process, so basically we get the data, clean it, visualize it, make data time series, make time series data stationary, plot the correlation and autocorrelation charts, construct an ARIMA model, and then finally use the model to make predictions. So basically we got the data from week 2 and it's a CSV file, and this CSV file we just read it, and it has 4 columns, and as you can see here, so we just basically read the data, and then we went to the next step, which is cleaning the data by renaming this column from unnamed to dates. And now I'm going to be moving to interactive session. Okay, so moving on to the next step, the interactive session using Python and Jupyter Notebook. So basically, we have a 100-line code here, and due to time constraints, I won't go through everything. I will just focus on the most important stuff. So remember the processing flow in the PowerPoint. So we start with get the data, we clean it, visualize it, and then make the time series data stationary. And what does stationary data mean? It means we have a constant mean, variance, and covariance, and they're not changing over time. So there are mathematical statistical models to test the stationarity of the data, such as the Augmented Dickey-Fuller's Test, ADF, using Python stats model. So I'll show you quickly here. So what we do is start off by importing the relevant libraries, pandas, and stat models. So we read the data in, we check for any missing values, and then next step would be visualizing the data and using the EDF test that we do here. And in here, what you have here in this graph, we have a rolling mean and standard deviation using for Apple. So the blue curve is original price, the orange curve is the rolling mean, and then the black curve is the rolling standard deviation. So, and then we do the same thing for Microsoft, ExxonMobil, and then SPX. So, and the next step, we go through the error and trend decomposition, which I'm not going to go through due to time limit. Okay, so next step is test data stationarity. So using ADF test, which is Augmented Dickey-Fuller test. So the null hypothesis here, a non-stationary time series. Alternative hypothesis is that the series has no unit root and is stationary. We're going to decide on this based on the p-value, and there's two outcomes. The first outcome, if return a small p-value, typically less than 0.05, indicates a strong evidence against the null hypothesis, mean rejection of null hypothesis and stationary, and thus we have the stationary time series. And the second outcome is that return a large p-value greater than 0.05. This indicates weak evidence against the null hypothesis, mean we fail to reject the null hypothesis, which means the data is non-stationary time series. So to summarize the results here, so we did this test for each stock for Apple, Microsoft, ExxonMobil, and SPX. And we got the values, and here to summarize, we get this table, and in this table we found out that Microsoft is a stationary data set because its p-value is 0.048, which is less than 0.05. Okay, so note that we have now realized that our data is seasonal. This means we need to use seasonal ARIMA on our model. If our data was not seasonal, it means that we could use just ARIMA on it. We will take this into account when differencing our data, which is next step. Typically, financial stock market won't be seasonal. And final thoughts on the autocorrelation and partial autocorrelation tests. So identification of an AR model is often best done with the partial autocorrelation function. For an AR model, the theoretical PASF shuts off past the order of the model. The phrase shuts off means that in theory the partial autocorrelation are equal to 0 beyond the point by the order of the model. We mean the most extreme lag of X that is used as a predictor. Identification of MA model is often best done with ACF rather than PACF. For an MA model, the theoretical PACF does not shut off, but instead tapers down towards 0 in some manner. A clear pattern of MA model in ACF, the ACF will have non-zero autocorrelation only at lags off and involved in the model. Finally, we go to the final version, so which is the final prediction of future values. This graph shows Apple original price in blue curve versus the predicted price in orange curve for the past year 2011, and it looks like it's giving us good prediction. Now we move to the next session, forecasting in Tableau. So this interactive session of Tableau, and what I wanted to show you here quickly is the forecast options. Right click and click on forecast, and then forecast options. Here you have some options between trend and seasonal, and then you have the option between choosing between additive or multiplicative way. So when you play with these parameters, then it gives you a different model. Now the next section here, we'll go and click on forecast and then describe forecast, and here we have two tabs. The first tab is summary, and the second tab is models. So when you go to summary, looks like we have a good quality model, good quality. This is the way where we can test our model using Tableau. And then here we're gonna focus on the mean absolute square error, and it's 0.24. So it's 0.24, which gives us a good model. And so the quality of the quality of the model is proportionally related to the mean absolute scaled error. And so if the error is above 0.8, then we get a poor model. However, if the model is lower than 0.4, then we get a good model.
So I'll wrap things up now with the cost-benefit analysis now that you've seen all the four models. For our cost-benefit analysis, we actually applied a SWOT matrix to these four different models to compare and contrast them. And feel free to take a good look at this table and read it over time for a more comprehensive view. For myself right now, I'm just going to draw a couple of conclusions that came from this SWOT analysis, which were really that of these four models, they broke into two tiers. There was the ARIMA and portfolio optimization, which were the most accurate, the most customizable, that you could tweak and improve them over time, especially if you could get live data sets. Now, Tableau and Power BI were much easier to use. They were easy for an amateur investor to plug in, and they could be tweaked and also measured, but didn't have that same forecasting strength. What we realized, though, is that all models showed some efficacy and were an improvement over the gut instinct, that they did have some predictive power and could be helpful for amateur investors.